Welcome to the mysterious depths of our oceans, where the pressure is crushing and the environment is far from the tranquil scenes we see at the surface. We're about to embark on a journey into a world that is both fascinating and daunting, a world that is largely unexplored and full of enigmas waiting to be unraveled. This is the deep sea, a place that is as alien to us as the farthest corners of the universe. It's a realm where sunlight fails to penetrate, where the temperature is icy cold, and where the pressure is so intense that it can crush even the most robust submarines like a soda can. Despite these extreme conditions, life not only exists but thrives, with creatures that have evolved to withstand the immense pressures and low temperatures, exhibiting a resilience that is nothing short of extraordinary. But our journey today is not just about exploring the wonders of the deep sea. It's also about understanding the challenges that this unique environment faces. You see, the deep sea is not as isolated from the surface as we may think. It's affected by processes and activities that occur above, in the world that's familiar to us. One such process is eutrophication, a phenomenon that is driven by an excess of nutrients entering the ocean waters. It's a process that begins at the surface but has far-reaching impacts, even in the abyss. Eutrophication can disrupt the delicate balance of life in the deep sea, creating dead zones where oxygen levels are so low that most marine life cannot survive. Our exploration today will take us into the heart of these issues. We'll delve into the science of pressure in the deep sea, how organisms have adapted to survive in such extreme conditions, and the impacts of eutrophication on this unique environment. So buckle up for a journey like no other, as we dive into the mysteries of the deep sea. Join us as we unveil the secrets of the deep. As we journey from the light-filled layers of the ocean down into the abyss, the pressure increases dramatically. Imagine, if you will, the weight of an elephant standing on a postage stamp. That's approximately the amount of pressure you would experience at the deepest point of the ocean, known as the Challenger Deep. Located in the Pacific Ocean's Mariana Trench, it reaches a depth of nearly 7 miles. Imagine now you are taking this journey into the abyss. As you descend, for every 33 feet, or about the height of a 3-story building, the pressure increases by another 14.7 pounds per square inch. That's equivalent to the atmospheric pressure we experience at sea level. By the time you reach a depth of 1,000 feet, the pressure is already 30 times greater than at the surface. But the pressure doesn't stop mounting. Plunge even deeper to the midnight zone, where sunlight doesn't penetrate, and the pressure is a staggering 1,000 times greater than at sea level. This is an environment so hostile, it seems inconceivable that anything could survive here. Yet life thrives under these conditions. Deep-sea organisms have evolved unique adaptations to survive the crushing pressure. They don't have air-filled spaces like lungs or swim bladders, which would be crushed under the immense pressure. Instead, their bodies are primarily composed of solid tissues and water. Many deep-sea creatures, like the fangtooth fish or the giant squid, have also evolved to be soft and compressible. Their bodies lack rigid structures that would be vulnerable to the intense pressure, allowing them to withstand the harsh conditions of the deep sea. But perhaps one of the most fascinating adaptations is found at a molecular level. These organism cells contain special molecules called piezolites. Piezolites help proteins maintain their shape under high pressure, allowing these creatures to exist where it seems impossible. Take, for instance, the barrel-eye fish. This strange creature has a transparent head filled with jelly-like substance, allowing it to withstand the pressure while giving it the ability to look up through its transparent skull for prey. Or consider the Hadal snailfish, a fragile, gelatinous creature that lives at depths of up to 5 miles. It has evolved a body structure that perfectly suits its high-pressure environment. These are just a few examples of the incredible adaptations that allow life to flourish under the immense pressure of the deep sea. It's a world that seems alien to us, but it's home to these remarkable organisms. They've not only survived, but have evolved and thrived in these extreme conditions, demonstrating the amazing resilience and adaptability of life on Earth. Yet life thrives under these conditions. Deep-sea organisms have evolved unique adaptations to survive the crushing pressure. It's a testament to the extraordinary resilience of life and a reminder of the mysteries that still await us in the unexplored depths of our oceans. But the deep sea faces challenges not just from within, but from above. Eutrophication, a process driven by excess nutrients entering ocean waters, can have profound impacts, even in the abyss. Eutrophication. It's a term that might seem complex, but its essence is quite simple. It refers to the excessive richness of nutrients in a body of water. This overabundance is typically due to runoff from the land, and it creates a dense growth of plant life, particularly algae. Now you might be thinking, more plant life? That doesn't sound too bad. But here's the catch. When these algae die off, they sink to the bottom of the ocean, starting a chain reaction of ecological effects. As these algae decompose, the process consumes oxygen in the water, creating areas of low oxygen, or hypoxia. This is where the real trouble begins. Many marine organisms, from the tiniest microorganisms to the largest whales, rely on oxygen dissolved in seawater to survive. When oxygen levels dip too low, these creatures either flee the area or perish, creating what we call dead zones. But wait, you might say, aren't we talking about the deep sea? How does surface runoff affect ecosystems thousands of meters below? Well, that's the insidious nature of eutrophication. It's not just a surface problem. The nutrients that fuel eutrophication primarily come from agricultural runoff. Fertilizers rich in nitrogen and phosphorus, used to boost crop yields on land, wash into rivers and eventually the ocean. Once there, they fertilize the ocean too, triggering explosive growth of algae in surface waters. When these algae die, they don't just vanish, they sink, taking the effects of eutrophication with them into the deep. As this organic matter decomposes, it consumes oxygen all the way down, carrying the threat of hypoxia into the abyss. This is how eutrophication bridges the gap between land and the deep sea, how human activities on the surface can have profound impacts in the deep, unseen world below. And the effects can be devastating. Dead zones are essentially biological deserts, areas where life as we know it struggles to exist. The loss of biodiversity in these zones is a serious concern, not just for the organisms that call the deep sea home, but for us as well. The deep sea plays a crucial role in global nutrient cycles and climate regulation. What happens there doesn't stay there. Imagine a world where the deep sea, a realm of incredible pressure and darkness, teems with life, where strange and wonderful creatures have adapted to thrive. Now imagine that world slowly suffocating as the oxygen it relies on is steadily consumed as dead zones spread. This is the threat of eutrophication. It's a threat that comes from above, but its effects are felt far below, in the crushing depths of the deep sea. This nutrient overload can create dead zones in the deep sea, areas where oxygen levels are too low to support most marine life. The deep sea is not isolated from human activities. Eutrophication represents a significant threat to deep sea ecosystems. These words, spoken by our featured marine biologist, highlight a grave concern. The deep sea, an environment already battling extreme pressures, now faces an additional threat from above. Eutrophication, a process fueled by an overabundance of nutrients primarily from agricultural runoff, is causing a ripple effect that reaches the very depths of our oceans. Excess nitrogen and phosphorus nurture algal blooms. When these blooms die off and sink to the ocean floor, their decomposition consumes oxygen and releases toxins, disturbing the delicate balance of deep sea life. The marine biologist explains further. This nutrient overload can create dead zones in the deep sea, areas where oxygen levels are too low to support most marine life. Imagine a world devoid of life, a barren wasteland. That's what these dead zones are like, and they're growing. The effects of eutrophication are far-reaching. It doesn't just disrupt the ecosystems within these dead zones, it also threatens the biodiversity of the deep sea, a place teeming with unique life forms, many of which are still unknown to us. Our expert warns, deep sea organisms have evolved over millions of years to survive in an environment defined by extreme pressure and limited resources. Eutrophication adds another layer of stress to these ecosystems. It has the potential to cause extinctions and fundamentally alter deep sea life as we know it. The deep sea, often out of sight and out of mind, is not isolated from the effects of our actions. The nutrients that we allow to leak into our oceans are disrupting ecosystems and threatening marine life. It's crucial that we address nutrient runoff at its source to protect these vital and vulnerable habitats, our expert concludes. Our actions on land have consequences that reach the depths of the sea. It's up to us to mitigate these effects and protect the mysterious and precious world beneath the waves. Addressing the challenges of eutrophication involves reducing nutrient runoff through better agricultural practices. It's not just about stopping the flow of nutrients into our oceans, but also about changing our approach to farming and agriculture. This might sound like a daunting task, but with the right strategies in place, we can make a significant impact. Firstly, implementing precision farming techniques can play a vital role in reducing excess nutrient runoff. These techniques involve using technology to apply the right amount of fertilizers at the right time, reducing waste and limiting the amount of excess nutrients that can potentially enter our waterways. Secondly, the use of buffer zones around waterways can also help to absorb and filter out nutrients before they reach the ocean. These zones, usually filled with native vegetation, act as a natural barrier between agricultural lands and nearby bodies of water, helping to keep our oceans clean. Thirdly, promoting sustainable farming practices, such as organic farming and crop rotation, can help to maintain soil health and reduce the need for synthetic fertilizers. These practices not only benefit the land, but also contribute to reducing nutrient runoff. Of course, these solutions are not one-size-fits-all. Different regions with their unique agricultural landscapes and practices may require different strategies. That's where the importance of knowledge sharing and international cooperation comes in. By learning from each other's successes and challenges, we can collectively work towards more sustainable agricultural practices and a healthier ocean. Furthermore, policy changes at the governmental level can also drive significant progress. By enforcing strict regulations on agricultural runoff and providing incentives for sustainable farming, governments can play a pivotal role in addressing eutrophication. It's a global effort that requires cooperation and commitment to protect our oceans. Every action, no matter how small, contributes to the overall health of our marine ecosystems. Remember, each step we take towards reducing eutrophication is a step towards preserving the extraordinary environments of the deep sea for future generations. The deep sea, with its incredible pressure and unique ecosystems, is a reminder of the resilience and fragility of life on our planet. This hidden world beneath the waves, steeped in darkness and mystery, is home to an array of life forms that continue to baffle and amaze us with their adaptations to the extreme conditions of life in the deep. However, these extraordinary environments are under threat, not only from the crushing pressure of the waters above, but also from impacts that originate on land. As we've seen, eutrophication, fueled by nutrient-rich runoff from agriculture, can trigger a chain of events that disrupts the delicate balance of life in the deep sea. Creating dead zones where oxygen levels plummet, this process can decimate marine life and threaten the biodiversity of these unique ecosystems. The deep sea, being out of sight and often out of mind, may seem distant and disconnected from our daily lives. But the truth is, what happens in the depths of our oceans has far-reaching impacts. The health of deep-sea ecosystems is intrinsically linked to the health of our planet as a whole. They play a critical role in regulating our climate, absorbing carbon dioxide, and providing a home to countless species. The challenges facing the deep sea, such as eutrophication and pressure, are formidable, but they are not insurmountable. Solutions exist and are being implemented. Reducing nutrient runoff through improved agricultural practices, such as using less fertilizer and establishing buffer zones around water bodies, can help curb eutrophication. Policies and regulations that protect deep-sea habitats from overfishing and pollution are also crucial. But these efforts aren't enough on their own. Protecting the deep sea requires a collective commitment. It requires us to understand and appreciate the value of these hidden ecosystems and to take action to ensure their survival. Whether it's making more sustainable choices in our daily lives, supporting policies that protect our oceans, or simply raising awareness about the importance of deep-sea conservation, we all have a role to play. The deep sea is a world of extremes, a testament to life's incredible ability to adapt and thrive under the most challenging conditions. But it's also a world under threat, a world that needs our help. Just as the deep sea affects us, so too do our actions affect the deep sea. We have the power to make a difference, to safeguard these extraordinary ecosystems for the generations to come. By understanding and mitigating impacts like eutrophication, we can help preserve these extraordinary environments for future generations to explore and marvel at. Our oceans are a testament to the resilience and wonder of life on Earth. Let's work together to ensure they continue to inspire and amaze us now and in the future.